So we are starting off today by working on some code generation that I use this interface definition to define all of the syscalls that I support. So syscalls, and then I do the same thing for error numbers. The idea just is things that are the same between user mode and kernel mode should not be duplicated. I just have this one definition file that generates code for both of them. And this is the version right now, the Nightingale interface / syscalls. This is the one that I'm using today. And, it looks fine, right? You can kind of figure out what's going on here. Syscall number 2 is called exit. It takes a parameter exit code. It's void and return, and it doesn't return. It returns a value void, but never. I guess open is probably more clear there, right? Open is a function. It takes a pointer to a string, some flags, a mode, the mode being like, are we opening for reading or writing? And then it returns an integer, which is the file descriptor or an error. And this is fine, and it works, but it's not C syntax, and I want it to be C syntax. And the reason that it's not C syntax is that I wrote sort of a really bad parser in quotes that could get as far as basically construct and single pointer indirection. This is a code generator written in Ruby, and I didn't write a good C parser. So the thing that I'm exploring right now is what happens if I use a real C parser. So I've got this Ruby gem called CAST. Its whole thing is you give it for C translation units, and it turns them into it can do a whole C program into an abstract syntax tree. I'm just going to use it for these declarators of name, real C function parameters, and the value. So we're just playing with this right now. If I come up with something good, maybe we'll switch it out, maybe we won't. And once we're done playing with this, I think we're going to move and do some networking code, because I really want that to work. And it doesn't right now. So for now, I've made a bit of a start on this earlier. And we're just going to see what else we can do. So for the moment, I have got a file called syscalls C parsable that contains the same data that we saw before, just instead of being in weird, custom syntax, this is much closer to something that looks like C. It's not fully C, right? Because in C, you cannot assign to a function declaration. If these were pointers, you could assign to them, but even then these are integers. So this would not parse as C, but it gets as far as an abstract syntax tree. It does not type check as C, but it does parse as C. I guess that's what I should say. So the hope is, and this lets me do things like in the previous one, I couldn't support a double indirection, right? I just had to have a special case coded, and actually this type in the Nightingale, the current one, this type is just called args. Car star con star is just called args. So this lets me use the real type and print it out correctly. And we are that far. If I run this Ruby, I changed something. D dot, what's D? Decal dot indirect. That should now work. So this is what it's currently parsing to. I've got the name for each. I guess I can add like a new line or something. Sympho's each SI. Puts SI. All right, so this is now one line for each, and you see it's wrapping because the screen isn't very wide, but one line for each syscall, and we're printing out the name of the syscall, the name that I'm going to use in the enum, which is ng underscore all caps the thing, the number, the value, the syscall number that actually gets passed to the kernel, the user mode signature, so this is what's going to be generated into the user mode side code, and the kernel side signature is what gets generated into the kernel side code. And I know there is some this is the current production version of this code is right here, and you can see it's 300 lines, and this is also doing air nose. I want to do air nose in a separate file so that they're not conflated. But air nose is pretty short. It's also, this is all, you can see, super object oriented, and I don't like it. I want it to be better, and that's what we're working on. And you can see I've got these like special cases for different kinds of formats. This is a lot of the code that I need to write now. This is actually sort of the next thing that I was going to work on is the other thing that this generates. This does not just generate those headers. It also generates other metadata. So this is what, if I go to Nightingale, this data is what is used to produce the strace output. So all of this comes from that generated data. Well, here's that name. That name was generated from the syscalls thing. The fact that this is a string was generated from the syscalls output by looking at the type, right? It looked at the type in the generator. The type was a string, so what it output was the string. Ditto this pointer. It said, oh, that's a pointer, so I'm going to output a pointer. This is a pointer as well. Pointer that's null prints as null. This is a number, so it printed out as a number. And that's what I want to recreate without as much special casing, without as much nonsense. This all goes to it's all in the build directory because now it gets, I used to build it straight into the include directory, but now it gets built, now that I build through CMake puts things in the build directory by default, so you can see them all there, all the things that this creates. Auto-generated everything, and if we just take a look at sort of the style of thing that we're trying to create, we can see like we have auto-generated syscall names, for example, and this is just hey, this is an auto-generated file. These are all the names for this enum. The ng underscore exit, the name of that is underscore exit. For the ng underscore syscall underscore trace, the name of that syscall is syscall trace, and that's it. That's all this is. And we've got a syscall consts.h, which this is where the syscall numbers are generated, including the count of them, right? You can count them if you look at syscall max. Syscall's user.h contains this is the header file that contains all of the signatures that are needed for user mode code. So user mode code, specifically the .c file, all of those prototypes are in the header file. The .c file, this is actually, I think, some of the most interesting. This is the most helpful thing, is that that syscall, actually calling a syscall, is this syscall1 with the parameters. And so I've got these wrappers around all of the syscalls that gives me a real C function and deals with setting errno. Like, all of this is very convenient. And I just want it to be a little bit better. So that's what we're working on. And right now it works pretty well. The next thing that I have to do is solve the format strings and the pointer verification numbers. So type as pointer, I think, is going to be pretty easy because it's just type C pointer, type dot type specifically, I think. Or I guess I can just say, yeah, I should be able to just do that basically. And then the format strings are going to be a little bit more challenging, I think. And in order to do that, I think we're going to introspect this a little bit more. So this is entities 0, declarators 0. That's our function. Indirect type help if I spelled that right. Indirect type is the function type with parameters integer and pointer to integer. Params 0 dot type is capital I int, which I'm guessing, yeah, that's C : int, and params 1 dot type dot class is going to be C : pointer. And then the subtype is dot type, which is really interesting. So I do need to care about that subtype. And I also need to care about, a couple of things. I need to care about cint. I need to care about C pointer. And when it's C pointer, I need to care about its subtype. Because C pointer, I mean, we can just say P for the moment. Just like every integer is a ZI. This is all, we can see this in the script generate. This is what we're trying to recreate, is that every integer, character, and then this number of custom types are formatted as an integer. Z means machine width, or the width of a size T. A uinputter is one of those. I'm not actually sure what's format arguments. ZI is that's not very helpful website. Z corresponds to the size of a size T, which is actually probably wrong. This should probably be a JI. I mean, they're the same. And literally here, I'm printing size T as a ZU. But when I pass these things in, I convert them to int max. I mean, it really doesn't matter. Inputter, sorry, not int max, inputter T. It really doesn't matter. And it really doesn't matter because all of these things are the same and they're all formatted the same. I mean, the formatting code literally just right. Case J, case Z, case T, like they're not differentiated at all. They're literally the same thing. So I shouldn't worry that much about it because all three of these are just size of void star, which is portable, right? This will work on both 32 and 64-bit. So I think we're not gonna think about that too much right now. But, right, this is now multiple things. And we have some questions about how this represents. So, like, that's an integer. What about, like, an enum? ABC. Type is enum. Well, that's easy enough. Because every enum name is going to be the same. And that's basically what we have here, right? Anything that starts with enum. What about, is long a separate type? It is not a separate type. It's cint with a longness set to 1. That's a really interesting way to represent that. But it's quite helpful because it means that I don't need to worry about that as being separate. Char is indeed a separate type. And what else do I need to care about? So there's these custom types that are going to be interesting. PID T, off T, mode T, S size T. These are things that I had to define, as well as all of these, size T, NFDs T, and Sockland T. So custom type is going to need a bit of a more, custom type. I believe custom type gets a parameter called name. Type def int x ABC. And that just didn't work, I guess. Type def. This library is kind of weird in that the parsing state is preserved as far as things like the name of this type is actually preserved across calls. See, now this works, except that it still doesn't have a type. Oh, because declarator 0, that's the problem. Declarator 0 is now the type def, which is not what I wanted. But now I should be able to get rid of that and it will be preserved across. So, I mean, I guess it's helpful in that sense. Yeah, so it's custom type and then name is the, it's just a parameter of custom type. So now I can just say case type dot name when PID T, off T, mode T, S size T, PID T, off T, mode T, S size T. These are all signed types, so they're ZI when size T, NFDs T, and Sockland T, size T, NFDs T, Sockland T, those are all unsigned. So they get printed as unsigned. And when sig handler, that is a pointer to a function, so it gets printed as a pointer. Pointers are pointers, except, so there's one more thing here. Case is it default? Apparently not. What's the backup case in Ruby? Case 1, when 2, that's nope, else. I guess it's else. Else. Give ourselves a little helpful message there. And in pointer, if it's anything that isn't char, if type.type is a character, we want to format it as a string, and actually specifically we want to format it as double quotes and then a string. And when it's a, we're going to leave it like that for now. There's something else that I want to do, at least potentially in the future, which is when we have a like an arguments string. So if I just strace, is this going to show it? It is going to show it. This argument to execv is an array of strings. I think it would be nice to be able to print the array of strings as an array of strings, as opposed to just the pointer address. The challenge there is really going to be that I need support in the printf formatting code to print out an array of strings, because there's no way for me to say like, oh, printf, as many %s's as you need to print out this array of strings. That's not. So I'll need either like a special print function, or I was considering having a %S or something like that that just knows how to format that, just as a non-standard extension. So that's definitely on the roadmap as far as things that I could possibly do, but it's not, I don't think we don't support it right now, and I don't think we're gonna bother trying to support it in the immediate future here. So what else am I missing? If it is a, that's an interesting question, is how does this represent const? Let's make this a const test t. Custom type const, which I'm going to hope is still a C custom type, and then it should probably just have a, dot const is true. Okay, so that makes a lot of sense to me, and it actually means that we are not going to need to deal with const at all. So pointer, if the pointer is a string, print it as a string. Else if it's a pointer, print it as a pointer. Else if it's character, integer, pit t, off t, mode t, size t, long, or enum, print that as an integer. We've got all of those cases. Else if it's a size t, nfts t, soclen t, that's unsigned. Else if it's a sig handler t, that's a pointer. Else unknown. So we have got all of the cases that I cared about, and we don't need to deal with args because I just support parse our console in this new version. So that looks like that should handle that acceptably. So that's the params. Params.map p type to, what did I call it? Type to format string. Join. I think I want that. And so this is the format params is that. The format string is name, user mode name, parenthesis, format params. And then that should go, shouldn't be called sting, it should be called string. String. And that should go in here as like format. So let's run that and see if it does something useful. It does not. Why not? If that's kind of annoying that nil doesn't just support a map. I feel like nil should just support a map implementation that never calls the block, but whatever. Okay, so that's always giving us nothing. Why is that always giving us nothing? That should return. I see no reason why that wouldn't return. I guess I probably shouldn't use 1, I'll use 0. So is it, I mean, it's clearly, the code is clearly getting there because we have multiple things in the join. Oh, because, okay, well that's that. The first problem is that these are printed after the fact. Okay, so this is just always returning nothing. So let's have a peek over here. Params is decal.indirect type.params. Params equals params dot each. Let's just print them out. That's params. That's exactly what I expected to see. Params 0 dot. Oh, right. Okay, that's the problem. Type to format string. I'm passing in the parameter when I should be passing in the type. And that looks better. I need a return format too. Decal.indirect type.params. What is the, right, because it's not even indirect type, it's declarators.type. type. What's the actual return type? Declarators.type.type. Declarators.type is function. I feel like I should almost assert that or something. The decal. Assert a keyword. Raise unless. Decal.type equals dot is C function. Is that how that works? Decal, let's test that. Yes. We'll be fine with that. Okay. So that's params. Return type is decal.type.type because that's the proper type of the returned. Yeah. Type to format string of the return type. Is the I? Yep. Cool. So the next thing that I think would care about are the parameter names, or more specifically, we care about the parameters cast to input-rt all, as we do in the well, let's get the names for the moment. That should be as simple as that, and that should just give me an array. Param names is the array, fdstatbuff, but that's not actually what I want. What I want is params casted equals param names dot, we're going to map okay, that seems to have worked. I care about how many params there are. Is that dot length or dot len? Dot length. That's getting pretty good. So now, with these infos, we could generate, I'm sure we'll find something that I've forgotten, but for the most part at least, we should be able to generate our syscall information. Right, so for example, we could generate our enum like this. Right, that would be our enum. Or maybe more specifically, indent it and add a comma. And then I don't know what I call it, but enum. Hey, look. So that's basically doing exactly what we had before, hopefully. And we'll still need to deal with putting things into file correctly. But honestly, I think this is a good proof of concept. And I think with it being a good proof of concept, I should, I think I'm going to pause working on this for the moment. And we're going to go do something else. Specifically, we're going to go do something else in about 2 or 3 minutes when I be right back. So I'm going to, yeah, I will be right back, and then we will get into maybe working on the networking code or maybe something else on my to-do list. Should be good. I'll be right back. I am back, and I had one thing occur to me that I just wanted to check before we move on, which is just I want to see if comments parse in this parser. And the answer is, yeah, no. Oh, because I mean, yeah, the answer is no. Comments are not preserved. They're just completely thrown away, which is kind of a shame. I was hoping I might be able to use... There is the one problem that I found with this parser is that it does not, it's limited to C99, and I am not limited to C99 in my project. So the problem with that I have found is with the no return specifier that I want to be able to, I know that's not going to do anything in Ruby. I want to be able to annotate my functions as does not return, and indeed I currently do, right? Exit is no return. There's a couple other ones in here. Exit group, shocking. Halt VM, that turns off the box. Exit thread, sig return, right? So mostly stuff that's going to exit the execution. And I want to be able to actually tell the system, hey, these are no return, so that I get that in C. And it turns out that this parser, the C-ast Ruby gem, does not support that. It just thinks that you have an invalid identifier. No return int. So that's totally valid C11, but you get this parse error on identifier no return because that wouldn't be valid C99, which is kind of annoying. And I haven't found another way to smuggle that through. I mean, I can certainly do something where like I snip that off in string processing before we get there and just don't pass it to the parser. But the big part of what we were trying to avoid was, right, what's so nice about this is that I can set that and then I can print it back out and you just get, like, it formats it correctly. I don't have to worry about saving this qualifier. The system, the parser just knows. So maybe I might even try adding it myself. Maybe. I'm not a huge fan of the idea of shipping a modified version of this gem, because then I would have to ship it with the system. Maybe I could try to get the change upstreamed, just as like, hey, this is a pure feature edition, no return is a reserved name, so it can't, in quotes, it can't break anything. It's backwards compatible in that way. That C says any global scope name that starts with an underscore is reserved for the implementation. So technically, if you're user mode writing C code, you're quote unquote not allowed to make a name like no return yourself, for this exact reason. And that's why when the C committee added no return, the standard form of the keyword is underscore capital N no return, because it's a reserved word. They did add lowercase n no return, but they put it in an opt-in header. So it's just a macro, because they didn't want to reserve a word that they hadn't reserved already. But I think that's enough on that whole rabbit hole. We've sort of proved the concept. I think it's worth further investigating, but right now I want to do something else. I want to work on some C code, get into the details, and I think we're actually going to start. We're gonna whet our appetites, as it were, by jumping into a bug that was actually pointed out by somebody on stream the other day, which is that my standard IO, my implementation of F reopen is kind of super messy. It is falling behind F open. F open I've made some improvements to. F reopen does not have those improvements. So it is doing the wrong thing in certain cases. It's leaving me with uninitialized files in other cases. And this is also not allowing any kind of freeing of this buffer. Like when I say fclose, well, that was a malloc buffer in fopen. So I should be able to free that theoretically, but I currently don't have any way to. And I think the first thing we're gonna do I have any kind of like flags? Where do I put the state information? I'd like to be able to have a flag. I guess it's file state, which are just, that's just 3 bits. Let's make these some bits though. That's 2, that's 3. And that's fine. And then what we can say is state malloc, right? So what I'm interested in doing is storing in the file object whether it was opened with malloc or not. So because bit 1 is number 1, bit 2 is number 2, number 3 is bit 1 and bit 2, and you're never going to be both in read mode and in write mode, except for append, which is kind of that. So I think we're going to have to make a couple of changes later on to like how we read this variable. And in fact, we should probably make a like state rw mask is 3. But we can then say like, hey, if the state includes state malloc, which we can just make the next bit, which is 4, then it's a malloc file. And then we can free the malloc files. The problem that we need to solve here is not every file was malloc. Specifically these, std in, std out, and std error, are static and they can never be freed. But everything else can be, as long as I say the state and of course we're doing this wrong. Right, so that's, hey, this was a malloc buffer. What is supposed to go in mode? Because it's not that. Enum file state is mode. Oh, that's kind of annoying. I should not have called it that. Because file mode is something else. That's the problem. State alloc malloc. And then fclose can say if well, I can't call this close. I'm interested in saving the error now, so that if close ffd fails, I want fclose to return that error. But if mode contains state malloc, we can free f and then return close result. Because it is legal to close standard input and standard output, They just happen to not, like, you can close those and you can reopen those, but you cannot free them because they are not freeable because they're static. So the next question, I guess, with f reopen is, does this stream have to stay valid, or is this stream consumed? If that stream is consumed, I can implement it just in terms of fclose and fopen. The freopen file opens the file whose name is the string pointed to by path name and associates the stream pointed to by stream with it. The original stream, if it exists, is closed. The mode argument is used just as for fopen. If path name is a null pointer, it changes the, oh god. If path name is a null pointer, it changes the mode of the stream. That I don't think I can support right now. Freopen reopens the path name that is associated with the stream. Specification for this behavior is added in C99, which says, in this case, the file descriptor associated with the stream shall not be closed if the call to freopen succeeds. It is implementation defined which changes of mode are permitted, if any, and are under what circumstances. So I can just say they are never permitted and under any circumstances. And that's okay for now. It does. So that is to say, if file name is null, freopen is going to fail and close the stream. But that's not particularly helpful for solving the rest of this problem. So the thing that I think I actually want to do is abstract this, have a like void fopen2, which takes a r star file name I can type, and I just want to put all of this in there. We're going to make this static, and we're going to give it an underscore so that you know that it's private. It is going to, and then it's going to take a file star f. It's not going to malloc or memset. It's just going to do all of the work into there. So fopen is going to malloc and memset, and then fopen into that stream, file name mode stream, return that stream, and this is void. It shouldn't be void. We should actually probably just return that in this case. Yeah, because then if it's null, so I guess really we should say if not ret, then we should free f so that we don't leak it and return that. That seems right to me. Allocate it, pass it to fopen2. If fopen2 returns null, free f because we're not going to use it. And then if it returns null, we return null. And if it returns the same stream that we got in, then we're fine. And the one exception to that is that this is just S mode. And if ret, then if not ret, free f. And we're going to just return early here because I still have to change ret to mode has to include state malloc because it's mallocked in this case. And then freopen, what we will say is, are there cases where freopen does not close, like if it fails? The primary use of freopen is to change the file associated with standard error, standard in, or standard out. Interesting. So we can start with if not file name. We definitely want to always close the old. We definitely want to yes, we definitely want to flush the buffer because we want to get rid of anything that's in there. We definitely want to close the old file descriptor. If we don't have a file name, that's it. We've failed and we should return null. Because we're actually going to put this in brackets just so that I can write a comment. In this case, freopen is to change the mode associated with the stream without changing the file. It is implementation defined, which, if any, mode changes are allowed. I currently define none. I currently define the set to be empty. Just because I can't support that right now without saving the file name in the stream, which is something that I really don't want to do. And then that even gets more complicated if you have something like, I'm saving the file name in the stream, but like you change the working directory. I'm kind of interested to know how that would behave, but I don't really want to write a test program to figure it out right now. Right, that let's say you open a file and the file is called like foo, and then you in the program you change the working directory to a different directory that has a file named foo. If you opened that file, if you did freopen with no file name, it's gonna make me curious. Vector dir echo hello world to dir/foo. So file foo is fopen foo for reading. Is it shader? Shader construct path. If not foo, return failure. Int just had enough of these things fail, and you can't tell where, that I'm just going to behave like it's go. If error, return nil. Or if error is not nil, return error. I'm just going to treat it like that. F reopen null r foo, and then buff 1024 f gets, what's the f gets signature? F gets is string size stream. Buff 1024 foo. We should probably actually check to see that this works. Because Linux might define that as illegal as well. And then this super doesn't need to be, we're going to make it like 128 because that file has like 11 bytes in it. And we'll put something in the old one too. That should be fine. Old file. So it does the right thing. The right thing defined as it actually reopens the file, the old file. So that means that if I was going to support that, right, the f reopen implementation inside my operating system would have to not just know the file name, the file would have to not just store its file name, it would have to store the like complete path or some sort of internal identifier in order to be able to find that same file again. So I think we're going to stick with defining that no mode changes are allowed and sort of not worrying about f reopen for now. That is a problem for another day. And then the other thing to do is just into that stream, f open to file name mode stream. So that should reuse the same memory. And we'll just want to make sure that we don't overwrite the malloc state that we just created. Because that would not be, it would not be good if we overwrote that, because then you would forget whether something was malloced or not, and then we would leak it. So we don't want to do that. What we probably want to do is say like bool was malloced is f to mode and state malloc, and then we'll just say or if we were malloced, else nothing. I mean, that's kind of messy, but it's fine probably for now. It's in the list of like stuff that I'll fix later. Not return. So I think that should work. And now I actually want to make I want to make a little test program, because I didn't realize that that was what that was for. Reading the f reopen doc, we got this note that the primary use of f reopen is to change the file associated with standard in, standard out, standard error. So I'm very interested to see if that works, and I don't have a program that's going to do that right now, so I think we're going to make one. Or actually, we could just check to see if I have if I'm using dupe in user, which I definitely am. Yeah, the shell makes pretty extensive use of dupe when evaling a pipe, but I don't actually think I'm gonna change. I'm not gonna do that right now, just because if I do it in the shell, that's gonna break everybody's like read and write to file descriptor 0, which is not really what I want to do right now. And then it looks like no other program uses dupe to set file descriptors, so we're gonna just make a test program and not worry about changing anything that exists. And I think we actually already have this just sort of. Does that not exist? Thought I had a program called XXX that was just, maybe I got rid of it at some point. I guess I did. So let's just make a program called XXX that just includes standard IO. We want to reopen some file writing standard out. So theoretically, that's going to redirect standard out to some file. Maybe. Okay, so we've got some syntax errors, file aim, file name, 311 stream, 311 stream. We have no stream because it's called F. And then xxx.c does not return a value, which is technically wrong because main doesn't have to return a value, but whatever. And that's instantly. Okay, didn't write the standard out. I see a file called some file, and it's got our text. So I think that works. And I think I don't know when that happened. So let's clean up a little bit. Actually, we should definitely commit this. This was work that we did before. Guard against housekeeping. Reopen and prevent memory leaks in fclose. That's probably good enough. And then the question is, do we actually want to commit user xxx? And I think the answer is no. So we're just going to go ahead and drop that. And that is one item off my to-do list. So so we could do that network program that I talked about, programming, which I kind of wonder if because I know there was a commit made some time ago, specifically version 0.11.0, which was some time ago. 0.11.0, I said Unix sockets work. That was November 29th of 2020. So that was a good more than a year ago, year and a half ago almost. But the question is, does any of this code still exist? Do Unix sockets in fact work? And we'll find that out in file system. We have socket file. We have sysun. We have user DG, which is an AF Unix socket. Kernel FS socket. All right, that seems logical that it might work. So DG, unsupported protocol. In what? Calling socket. Ops is get protocol, domain type protocol. Which is here. Which is here. Which looks through the protocols. And so do I ever call RgRegister protocol? No, I just never call this. But surely I can. Struct socket ops. Struct file aux socket ops. But I need a struct socket ops to register, and it looks like I maybe never make one of those to register. Ugh, I don't like this. This is why I want to redo it. Pain in the butt. I don't appreciate the way that this code is organized, and I don't really appreciate anything about the file system, which is part of what I'm worried about for doing this. But I was going to start with the driver code, which I've had in the past. ctl8139.c, which I've had in the past. I wish this log format had timestamps in it. Is this really my... I mean, I guess it is. I'm surprised that I don't have timestamps in my log format. May 14th, 2020, I removed all of the old bad stuff. And this is... Yeah, this is the, like, previous sockets implementation. So I had originally I wrote an implementation of sockets and networking in the Nightingale kernel itself first, back in like 2000 and a long time ago. Then in, I don't know, I think it was in 2019, and then big rewrite in 2020. I don't have it here. I could probably get it. If I clone, I think it's called IP stack. And this is an IP stack that runs on Linux and was much better, but it's still not any good. It's better, but it's still bad. And I spent a bunch of time trying to port that into the Nightingale kernel, but I had problems with some of the ways that it was architected, and I had issues. I mean, this is based around pthreads, right? So like if we look at iTCP echo, you know, I got to the point that I had a TCP echo server, which I think is pretty cool, but this runs as a pthread, and I was sort of hoping that, I think we can just see that at the bottom of, yeah, see, I'm creating pthreads for these different like services, and I was hoping that I could port that pretty easily because, well, a pthread would be pretty similar, hopefully, to how in-kernel threads were working, but it wasn't that simple for some reason. I don't remember why. So part of me wants to start again. And, you know, I've learned, let's make a new networking implementation starting from the top down. And part of me thinks that's a terrible idea because this already is 2,500 lines of code, and I don't really want to like sit down and bang my head against 2,500 lines of code, but it's not even... I don't know. What I do know is that I need to get some food in me, or else I'm not going to be able to think. So I am going to wrap this up for now, and I will probably be back on later after having eaten, and then we might be able to bash our head against this. But if I don't eat, I'm just going to get more tired, and if I get more tired, I'm going to get annoyed, and that's not going to be fun. So I'm gonna, like I said, I'm gonna wrap this up, and I should be back on later, and maybe we'll work on that networking, or maybe I'll have some inspiration for something better to do. Either way, I will see you later.